Welcome. This video on continuous functions is brought to you by the Learning Center at Vancouver Community College. Visit our website at www.vcc.ca/tlc for more information. We're looking for requests, so please submit your suggestions to mathsciencetutor@vcc.ca. The question is, for what value of a and b is the following piecewise function continuous over the real numbers? For most of the set of reals, it's already continuous. For any values of a and b, these expressions become polynomials, which is an example of an algebraic function. There's a theorem in your textbook that tells you that algebraic functions are continuous over their domains. The only places where this function might not be continuous is at the seams of the piecewise function, at x equals -1 and x equals 3. To prove continuity over all reals, we'll concentrate on continuity at those 2 points. The theorem I mentioned earlier takes care of everything else. The sticking point of the definition of continuity at a point is requirement number 2, since each piece of the function creates its own one-sided limit. We'll start with x equals -1. The left-sided limit uses values of x slightly less than -1, so we invoke the top line. And the right-sided limit uses values of x slightly greater than -1, so we invoke the middle line. The function can only be continuous if these two one-sided limits agree, so we can set them equal to each other. Similar reasoning will give us another statement for x equals 3 and what's required for continuity there. The results of this analysis gives us a system of equations that we can solve to determine the identities of a and b. We've demonstrated the computational side of this question. For a full solution, you'll want to write a logical argument covering the process that got us here. That's continuity at a point. If you'd like more help with your math and science, check out our website at vcc.ca/tlc.